So, today I want to dig into one of the most stubborn challenges we face when building capable AI agents: memory. I came across this fantastic post from Rooted Layers that really reframes the whole problem. The idea is we need to stop thinking about just cramming in more context and start treating memory as a real architectural system. It's a huge shift in thinking, so let's unpack this blueprint together.
And this quote from the post, it just hits the nail on the head. If you've ever built an AI agent, you know this feeling. It can do something amazing for one turn, but the second the job needs any kind of continuity, it's like it gets instant amnesia. It forgets key details, it starts repeating itself, and the whole illusion of intelligence just falls apart.
So why does this keep happening? Well, without a proper architecture, developers tend to fall into one of two traps, what the post calls bad defaults. On one hand, you have the stuff everything into the prompt approach, which, works right up until you slam into the context window limit. On the other hand, you have the dump it all in a vector store method. Over time, that so-called memory just turns into this noisy swamp, and your retrieval quality drops so low it's basically useless. The real breakthrough here, which the MemGPT paper highlighted so well, is that we have to stop seeing the context window as just a big bucket to fill. The entire mental model needs to shift. We should be treating it like a scarce, high-speed resource. And that simple change in perspective, it moves the problem from how do we get more context to the much more interesting question of how do we manage memory well. This leads to a really powerful analogy, thinking about an agent's memory like a computer's operating system. The context window is your RAM. It's incredibly fast, but it's also limited and expensive. Everything else, all that long-term knowledge, that's the hard drive. It's a bit slower to access, sure, but it's huge. So the job of a good memory system is to act like an OS, intelligently paging information in and out of that active RAM right when it's needed. Okay, so how do we actually build this memory operating system? The post lays out a super clear 4-part blueprint. Instead of one big messy pile of memory, we're going to architect it. By breaking memory down into 4 distinct, manageable types, we can create the structure we need to avoid that undifferentiated swamp we were just talking about. First up, short-term memory. This is basically the agent's active workspace, its RAM. The key here is to keep it small, clean, and focused only on the job at hand. The current plan, recent outputs, and that's about it. Next, we've got semantic memory. This is the agent's long-term library of facts. Think of it as its reference section. Things like company policies, product docs, user records. This is the stable, durable knowledge that the agent can pull up whenever it needs a specific piece of information. Then there's episodic memory, which is pretty much the agent's autobiography. And it's not just a raw log file of everything that happened. No, it's a structured record of its past experiences, its decisions, and, critically, its failures. This is what lets an agent actually learn from its own history instead of just making the same mistakes over and over. And finally, we have procedural memory. You can think of this as the agent's muscle memory. Once an agent figures out a successful way to solve a problem, it shouldn't have to reinvent the wheel every single time. That solution should get stored as a reusable skill, a template or a piece of code that it can call on later. But look, having these 4 memory types is great, but it's really only half the story. The next crucial insight is that memory isn't just a static database. It's a dynamic lifecycle. You need a system of policies that governs how information gets acquired, how it gets used, and, just as important, how it gets forgotten. And this lifecycle has a few key stages. Information is acquired from the outside world, then it's encoded into a useful format, the agent might derive new insights from it, later it gets retrieved and used for a task. But here's the kicker, the step we almost always overlook: it has to forget, or at least prune and summarize things, to keep the whole system from drowning in noise. Okay, so we've got the architecture and we've got the life cycle, but what does this all look like in practice? As builders, how do we actually decide which of these methods to use for any given problem?
And this really is the fundamental design question, isn't it? You can't just slap all these memory types on and hope for the best. You've got to be deliberate. And to do that, you need to really understand the trade-offs.
This table from the post lays out those trade-offs perfectly. For really short, simple tasks, sure, working memory alone might be enough. But the big risk is that it completely collapses the second the task gets more complex. For storing facts, semantic memory is your go-to, but then you have to deal with the risk of stale or just plain bad retrieval. Episodic memory is fantastic for learning from repeated tasks, but you have to actively fight against memory sprawl. See? It's all about matching the right tool to the right problem. So this leads us to a really practical idea, a disciplined build order. You don't have to build this entire complex system on day one. In fact, you probably shouldn't. There's a logical, step-by-step path to building out a really robust memory architecture.
Here's the sequence the post recommends. You start simple, with semantic retrieval for facts, paired with a small working memory. That's it. Then you add episodic traces so the agent can start learning from its past runs. Now, this is crucial. You introduce forgetting policies next, before your memory store gets out of hand. Only after that, once you start seeing successful, repeatable patterns, should you add procedural memory. You only bring in the really complex tools when your failure analysis proves you actually need them.
To really drive this home, let's talk about what not to do. Try to avoid these common anti-patterns. First, don't start with a giant, messy memory dump. You'll never find anything. Be super selective about what you save. Not every little interaction is worth remembering forever. This is a big one. Never treat retrieval as proof. Just because something is in memory doesn't mean it's true or even relevant anymore. And finally, always prioritize summarized facts over raw, noisy transcripts whenever you can.
And honestly, this quote from the post just wraps it all up perfectly. We have to get past this brute force idea of just longer context. The goal is a disciplined system. A system that carefully decides what little piece of information from a single run is valuable enough to become a durable, retrievable, and governable piece of knowledge for the future.
So that leaves us with one final and I think really critical question to chew on. If you really accept that memory is a core piece of the architecture, not just some add-on feature, how does that change the way we evaluate the agents we're building? It forces us to shift our metrics away from just asking, did it work this one time, and toward the much deeper question, is it actually learning and getting better over time? And that really changes everything.